Wow, we have multiple failed disk groups. Let's figure out some lessons learned so you don't have to go through the same pain I've gone through. Okay, I have 7 lessons learned on building a vSAN 2-node cluster. First, use a Witness virtual machine instead of using the vSphere appliance. So you have a couple of options. You can actually use the vSphere appliance, mount disks directly to the vSphere appliance, and have it do your witness management, or you can find the OVA that has the matching vSAN version and launch that virtual machine, and then have that virtual machine use part of the disk group that you have available, and that thing becomes your witness. So just to get our terminology right, you have ESXi, that's installed on each individual host that's going to be managing virtual machines. It's the main hypervisor. From there, you can stand up a vSphere appliance to centrally manage multiple ESXi appliances. And then once you have ESXi appliances, each ESXi appliance, or in this case a cluster, can run virtual machines. So a virtual machine is what you'll want to stand up, which will be a separate box or a separate virtual machine that will allow you to manage the witness aspects of things. In this case, it's sort of ESXi inside of ESXi, so you'll have an ESXi host, then you'll launch this virtual machine, which uses part of a ESXi microkernel. But long story short is use the OVA. I found it to be much easier. If you have multiple flash devices and multiple host bus adapters, then make your disk groups yourself. The reason you want to make the disk groups yourself is because if you let the automated disk grouping happen, then it won't necessarily put the same drives managed by the same controller on the same group. And so you end up with this weird case where if a flash device goes out, then it'll take down the entire disk group. Or if a host bus adapter goes down, it'll also take down all the drives associated with it. So you'll want to group those together. Also, the documentation highlights that you'll get better performance if you can align those. So don't let it manage it for you. Make it yourself, which is a little bit more work. One of the other things you can do is when you're looking at the drives, you can enable the column that lets you know which host bus adapter the drive comes from. So when you're manually making the disk group, you can actually see which ones need to be grouped together. When do you use a direct connected vSAN network? So I think you have to look at what equipment you have. A scenario I have is a good example. I have a 1 gigabit switch, but I have 2 hosts with 10 gigabit networking. So since I don't have the infrastructure for 10 gigabit to plug them both into a switch, I'm able to plug these devices directly to one another and get a much faster vSAN network. On the other hand, if my entire networking was 10 gig, then might as well just plug them into the switch so that in future times when I have capacity coming, it's a little bit easier to expand things. But in the case of 2 nodes, since the cost of upgrading to a 10 gigabit network is pretty significant, direct attached cable is only about $10. So I get a 10 gig network without all the other costs that come with that. Check the VMware compatibility guide. It's easy to forget the times when hardware compatibility wasn't such a big deal. Nowadays, if you're spinning up a Linux box, a Windows box, a BSD box, they have kernels and drivers support for just about anything. That is not true of the VMware microkernel. And when you're using things that's not supported, you can have a really bad experience or it simply won't work. So spend your time reading the compatibility guide. And there are multiple sections of the compatibility guide. So in this example, I can look at the I/O section, which is different than the CPU section. They have another one with chipsets on it. You need to understand, is every component in that system supported before you want to go down the VMware path? Otherwise, you might want to look towards more normal open source options. In my case, when I was looking to build out my system, just about everything I had was supported, but the RAID controllers weren't. So I had to swap out the old RAID controllers and hunt around to find some proper RAID controllers that weren't too expensive, that were supported for the VMware ESXi install as well as vSAN install. In my case, related to supported hardware, I went with the idea of going with consumer NVMe drives. Wait. Before you guys start yelling at me, I had a strategy in mind. My thought was that since the NVMe drives are just flash caches, I'm not using them as capacity drives, that I just burn them out when they had too many terabytes written, and I would just get new ones since they were so cheap. What turns out, the failure scenario when a cache drive goes out is not clean. The failure scenario when a cache drive goes out is it takes out an entire disk group, all of the disks associated with that cache. This is an example where reading the documentation is key, and also had I just gone with supported hardware, potential issues that I might run into would be significantly less. So I lost 2 disk groups, and when you look at each disk group failure, it talks about the NVMe drive not being available. And after reading the documentation and learning that you can lose an entire disk group when it gets unhappy with the NVMe drive, it seems that I'm running some pretty significant risk on this cluster. Now, I'm a glutton for punishment, so I'm going to ride this out and see how it goes, particularly since I got through the second round of performance testing. But just know, when you step out from the supported devices, you can run into all sorts of issues. The only silver lining I could say is that 2 disk groups failing, which was half my capacity, didn't take the cluster down. The workloads that I had already running just continued to run. It did a little bit of smart migration for the components it could actually migrate, and just continued to chug along. To make vSAN and ESXi happy, declare your target uplink ports related to each port group. So when you're in a port group, you can actually ensure that the uplink ports that are part of your uplink group are the ones you want to use. So within that port group, there's some settings, and you can get to your failover, and so you can set active, standby, and unused. And so you'll make these want to match the correct physical ports on each box that are relative to that port group. When you're setting up a 2-node cluster, prefer layer 2 over layer 3. So you'll get better performance with a layer 2 network. So wherever you can handle layer 2, make sure you handle layer 2. So layer 2 is going to be attached to the same switch. It's going to preferably use VLAN trunking, and that VLAN trunking is going to help identify what can see what packets. With layer 2, that essentially means that things need to be able to see unicast, broadcast, and multicast packets. When you're actually on the SSH console of an ESXi device, you can actually check an interface and also the interface tagging to see if the multicast and unicast components seem to be working. But essentially, you need to be attached to the same switch with VLAN trunking. You can also expand that network, so you can have multiple switches connected together, and so that's doing something like port grouping and sharing the trunking between them. That's a little bit more of a complicated setup, but it is possible to extend the fabric to multiple switches. But in a simplistic term, put everything on the same switch so that layer 2 communication can find each other, and that way it'll be a bit more performant than doing layer 3 routing. So the vSAN appliance has a few built-in, really basic testing, but also some interesting monitoring tools. But they also recommend HCI Bench, which is pretty cool. It's a VM you stand up. Once you get the main management console up, you can enter the credentials of your ESXi appliance, and then it will trigger spinning up multiple VMs up to 8 VMs running different workloads. So I went with the FIO workload. But the point here is that performance test your vSAN. Something might happen. In my case, I lost 2 disk groups. Why? Probably because I'm using unsupported NVMe drives. As I mentioned previously, go with the supported hardware list. So this is a good picture showing how everything is connected together. Once I got through stable testing, then I was able to start saying, hey, I think I'm pretty ready for to start putting workloads on here. I found going through all 4 of these tests took about 6 hours. So it's a good burn-in test to see how your cluster's working.